We have a container that's shaped of an open right circular cone. I'll be honest, reading the words open right circular cone, I would have thought, what the heck are they talking about? The picture is very helpful. Shown in the figure above, height of the container is 10 centimeters, diameter is 10. Water in the container is evaporating, so that the depth is changing. And then they say the depth is changing at a constant rate of this. So I've done enough AP tests to know that if I read the words H is changing at this rate, I want to write down a symbol, because the goal of any story problem is to get away from the story. Get right to math symbols. It makes the problem a lot easier to solve. So anyone have an idea of what I should write on my paper to reflect the fact that the depth H is changing at that rate? What do I want to write symbolically? Okay, everybody, hands up. About 5 people. So Nelson?
Like F of H or something?
You're on the right track. If I write F of H, what that means is there's some function value that changes based on the height. So right idea, but it doesn't really fit this situation. This is saying H itself is changing at this rate. So 2 points for Nelson. Other ideas? Hands? Let's go Logan.
Just H equals 3 over 10.
So, a small mistake, but I think I can help you see it. What does H itself represent, Logan?
The depth of the water in the tank.
Perfect. So H is the depth of the water in the tank, or as they're calling it, the height of the water in the tank. So the problem with saying that H is equal to negative 3 over 10 centimeters per hour is that's not really consistent with what H is. Yeah, does that make sense?
Yeah.
2 points for Logan. Else? Other ideas? Lieutenant?
Is it the derivative?
So dH over dt, which means the rate at which H is changing. H is changing by 3 centimeters every hour. Well, actually, every 10 hours. Said that wrong. So, show me your hand if you knew that before you said it. 2 points, 3 for 10. Question. Okay, I've been saying for a long time that you've got to get careful and you've got to get good at distinguishing when you read between what is an amount and what is a rate, because they're constantly testing that. Little, please.
Did you just write H prime, or would you have to have a
Gotcha.
function? Is that still valid or not?
3 points for Logan. Either one is the same. So those expressions are equivalent. Yeah, you can do either one. You'll see, I kind of go back and forth. It depends on the problem.
So why don't you have an x or a variable on the right side? Because right now it's just a constant. There's no equation.
Oh, I'll pay a ticket for that one. So answer this one, Jonathan, just so you can see it for yourself. Change the way you think just a little bit. You made a good comment. You said, wait a minute. It says dH dt is equal to this. And you said, but there's no variable on this side, correct? So you said it's not an equation. Well, it actually is an equation. The difference is, if there's, now really the variable that you might add would be t, because things are changing with time. They're not changing with x. So you might, I'll get the eraser to work. You might say, oh, there should be a T right here. But if you put a T right here, what are you now saying, Jonathan, about this rate? It's not necessarily the rate of the rate, but like, okay, everybody's got to see this. It's really important. Hey, Jonathan. Hey, look. It comes back to what we've been talking about all year long. You have to make sense of the idea. You just can't do math. We are fast approaching actual AP testing in this class, and you can't just do the math. You've got to understand what they're telling you. So, look at this. According to the story, please raise your hand if you can tell me. At time equals 0, what is the rate at which the height is decreasing? Like what would belong in this spot? At time equals 0, what goes here? Based on what you read, what would I say is the rate at which the height is changing at time equals 0? Hands up. Let's go, Jackson.
-3 centimeters per 10 hours.
So to just make the writing a little bit easier, I'm going to write -0.3. Same thing. Is everybody good with that? How many knew it? 2.3 for Jackson. This may sound like a trick question. It is not. At hour 8, please raise your hand if you can tell me what would be the value of dH/dt. At what rate would the height be changing at hour 8? Let's go along. Who agreed? 2 points, 3 for Lana. Now let's say this. Let's say the formula for dH/dt instead of just being -0.3, it's -0.3 multiplied by time. Like we add an extra t. Like that. Please raise your hand if you can tell me what would belong here if this was our equation for dH/dt. What would have to go here? Okay, come on. Daniel? This says if time is equal to 0, the rate at which the height is changing is going to be 0.3 multiplied by 0, which would be 0. How many knew that one before he said it? 2.3 for Daniel. The big idea is right here, when they tell you that the height is changing at a constant rate, that means time is not involved. It doesn't change the fact that there's still a formula for dH/dt. The formula for dH/dt is still going to be -0.3. That's a formula just like this is a formula. They're just formulas that mean different things. Does that answer your question?
Yeah.
2 more. We have a follow-up question.
Okay.
Please.
So then if I set an equation h of t, then I could say it's -0.3 t because that's, that's below the rate. That's the position of the water, right?
That is actually correct in this case. It wouldn't necessarily always be true, but because dH/dt is 0.3, that means the formula for the height of the water is actually going to be -0.3 t plus some constant that you don't know the value of. Yep. Please.
Is it okay for you to just throw in t because it wasn't defined in the problem? So, would the grader just be able to? Can the grader just always assume that t is time, or would you have to define that?
Oh, okay, take it for that. Hold on. The symbol lowercase t is reserved for time, so you don't have to define it. Is that what you meant? Yeah, it's perfect. Please.
Isn't the constant c 10? Because that's the initial height of the water.
Okay, take it for that one as well. Going with the way the story reads, well, be careful there. They actually don't say that the height of the water is initially 10, do they?
At the opening.
Oh, you're right, fair enough. So if we assume that the water was full at the beginning, then the initial height would have been 10, which means when time is 0, our height has to be 10. That's perfect. Well done. There you go.
But we should assume that it's full, right?
It turns out in this case, it really has nothing to do with what they're going to ask us to figure out. Yeah, you never want to really, yeah. They don't say that the water is necessarily full at the beginning. They just say the container's that large, so it could hold 10. But the assumption's reasonable. Like, I'm not going to use it for this problem, but what else? Okay, please, again, reminder, don't let anything we discuss just kind of float by. Like, I was watching a YouTube video this morning on how to do some type of car repair I'm working on at my house, and I caught myself thinking about how you are thinking when we're learning calculus, because that's what I was doing, was like trying to learn this new idea, and I found myself having to stop the video and wait a minute, what did that mean? I have to back it up. That's what I want you doing in class, is if something goes by in your brain and says, I didn't really catch that, just tell me to back it up and we'll talk again. So, questions? This difference is actually crucial. There were some number of people who mistakenly thought they should do this when they should have done this on the last test, and it did cost them 12 points. So, questions? Okay, so that's the background. That's what the story is talking about. They give us a formula for the volume of the cone. And that's pretty common. They don't ask you to remember a lot of obscure formulas, so they will expect you to know this. The area of a circle is pi times the radius squared. They will expect you to have memorized that the circumference of the circle 2 pi times the radius. So, and there's a few other we'll have to memorize, but not very many. Okay, the question says find the rate of change. So read slow and careful. Rate of change of the volume. Okay, you need to be able to translate those words into a symbol. So raise your hand if you can tell me what symbol should I write on the board that represents the rate of change of the volume. I'm not looking for an answer, I'm just looking for a symbol that I can use in my work. So what's the symbol that represents the rate of change of the volume? If you think about what we just did, we just had a big lengthy discussion about the symbol that represents the rate of change of the height. So now they're talking about the rate of change of the volume. So what is the symbol that represents the rate of change of the volume? I'm hoping for a few more hands because I'm hoping you can see the connection. That's better. Let's go, Edward.
V prime?
So because
d over t, or dt.
Because h prime of t represents the rate at which the height is changing, or dh dt. Therefore, dv dt, or v prime of t, capital V, small v is velocity, will represent the rate of change of the volume. Show your hands if you know it. 2 points. Okay. 3 for Edward. Please, Greg.
Could you use any letter if you wanted to?
So V is reserved for volume because they've already done it here.
Okay.
So I prefer to use that just because they gave it to me. But no, if you write down on your paper that, I don't know, G of t is going to represent the volume, totally fine. In that case, you would have to define it. Yep. 2 more. Anybody else? Okay. So we're trying to find this right here. Questions? Please, Matt.
Why did you write it as v prime of t when the original equation is only v?
I'll pay a ticket for that. it goes back to, again, getting really good at distinguishing the difference between an amount and a rate. So V is the amount. V is the volume of water at any moment. Because the water level is dropping, the volume is changing. It's never the same. But at any given moment, there will be some volume of water in the tank. That's what V is. V is the amount. V prime, or dV dt, is the rate at which that amount changes. So because they're asking for the rate of change of the volume, not the volume, I've got to focus on dV dt, not V. I don't know if I answered your question.
I was more asking like why you added like how you went V prime of T, where the original equation was just V and then add V.
Oh, awesome. Answer this question, everyone. This is another ticket for that. This is a really good question. What is the difference? Like, really, I want you to talk to each other about this one, and I want some hands. There is a key difference between this symbol's meaning and this symbol's meaning. Who knows the difference? Feel free to talk. You need to see it. Like, there's a difference. Like, I don't ever talk about things in class. Rarely do I talk about something in class. It's like, hey, this is interesting, but you don't need to know it for the AP test. This really helps. It's a really good question. There we go. Go on. What's the difference between these two? Hands, come on. Let's go, David.
The first is just V, is like in respect to the radius and height, so it's like just the number, that's just volume, whereas the other one is a variable, like it changes as your volume changes.
Very good. Do you want to add something to that? Please, Daniel.
So my understanding is just the V equals 1/3 pi r squared. H is the actual cone itself, the full cone, whereas V of T is the changing of the water. It's the actual water's volume.
Both statements were well said. Let me see if I can kind of summarize. If you had your hand raised, give yourself 3. And if this doesn't answer your question, Matt, keep asking. I can use this formula to calculate the volume of the water at any moment, as long as I know the radius and the height at that moment. That's the purpose of that formula. But because they're describing a situation where, as time goes on, the water level is dropping, it is appropriate to refer to the volume as V of T, meaning the volume will be different at different times. If I write V alone, I'm kind of implying, although we get lazy about it, I'm kind of implying that the volume isn't ever going to change. It changes, it's dropping. As the volume drops, the radius changes and the height changes. So this formula is actually not enough room on the board. That's the volume as a function of both radius and height. You probably have never seen that written before, but that's really what this means. That as the radius and the height change, the volume will change. But the volume is also changing with respect to time. Like, you really have stumbled across a really good question, because it's really getting into math that starts to look at a bunch of things happening all simultaneously. I don't know if I helped at all. Anybody else? Cool. Again, make sure you distinguish the difference between the rate at which the volume changes and the volume itself. Those are different. Questions? Okay, in this problem, they want us to find the rate at which the volume is changing. They want us finding this. And they want us to find it at the moment the height is 5 centimeters. So what you have to imagine is you have to visualize the water level dropping, going down. It never stops going down. It's just always going down. But at the exact moment when the height is 5, they would like to know how fast is the water level dropping at that moment. Questions? Okay. This is a particular family of problems that show up on the AP test regularly. It's what's known as a related rate problem. They won't tell you that it is a related rate problem. You have to decipher that on your own. The way you decipher it is from the reading, you should be able to tell that they're asking you to find one rate and they're giving you another rate to help you find it. So they're asking you to understand how two rates are related to each other. That's why it's called related rate. Questions? Cool. So let's work on this. A student 12 years ago, she gave me an acronym. It's not really an acronym, it's more like a guide that does help solve related rate problems. She found this on the internet. Another teacher was using this one. The acronym DREAD, like the Dwight Pilot Wobbits and the that joke didn't go over very well. Princess Bride. Okay. So the D stands for, you can see over here, I said help you with your notes. The D is for Danica's chart. Like I don't need the increasing, decreasing stuff. I just need to remember that a related rate problem is all about amounts and rates. Amounts and rates. So I make a quick table, amount and rate. That's what the D stands for. So first thing is, from the reading, you do have to deduce that it's a related rate problem. Then you go, okay, related rate, and you use the DREAD kind of idea. Second one right here. You're going to read the problem. You're going to write down, sorry I had to use the letter R again. Write down all the rates that you read about. As we read the problem, raise your hand if you can tell me what were the rates that we read about as we read the problem. Hands up, come on. We've already talked about it. Paul?
Maybe 3 centimeters for 10 hours.
So that is definitely one rate we read about. More important than the number is, what is that the rate of, Paul?
Height.
Height. And what is the symbol that represents that rate?
H
H prime or dH dt. So you're going to write here dH over dt equals negative 0.3. Okay, raise your hand if you knew that before Paul said it. 2.3 for Paul. You can't have a related rate problem with only one rate. Makes no sense. There's no rates that are related. So there has to be at least one other rate, sometimes two or more. So hands up, what's the other rate that you read about? Right here. What's the other rate that you read about in the problem? Hands, come on. That's better. Allison? The volume. So I need a symbol for that. So Allison, what's a good symbol to represent the rate of change of the volume? Which really is a nice symbol because it rolls off the tongue. dVdt. How many knew it before she said it? 2.3 for Allison. Question? Cool. This little note here, I didn't have a good way to include that in the algorithm, so oh well. Once you write down the rates, that should be your little clue that you need something in the amount column that corresponds to the rates. If we have the rate at which the height is changing, we also have the height itself. And if the color coding's off, it's going to bother me. Similarly, volume. Questions so far? Please.
Isn't the radius also an amount that you have?
I'll pay a ticket for that. There definitely is a radius involved in this problem. They don't talk about the rate at which the radius is changing, so I'm not sure yet whether I'll need it or not. So I usually don't worry about it if they don't talk about it, David, because I've seen problems where that'll get me stuck if I start worrying about too many things simultaneously. So even though it appears the radius will be important, I'm just going to leave it for now. Other questions? Okay, next step in the process. Write an equation that uses the amounts. And often they will simply give you the equation, although there are cases where you have to come up with one. They don't usually ask you to think too deeply. So they gave us the equation right here. That's the equation that involves the amounts. So I write on my paper, V equals 1/3 pi r squared h. Questions? Last step, differentiate the equation with respect to time. That means I apply the derivative operator to both halves of the equation. So I apply d over dt to both halves. Like that. Questions? Now I just apply the rules that you studied in October. So this will be dv dt. One-third pi is a constant.
The next graph. Get it right here.
Just say yes or no, please. As the water level is dropping, is the value of the radius constant or changing? Say it. Okay. As the water level is dropping, is the value of the height constant or changing? Say it. Awesome. So the radius changes with respect to time. The height also changes with respect to time. Both are variables. So when I take the derivative, when I differentiate, I have to use the product rule. So parenthesis, second, multiplied by derivative of the first. We're at the point in the year where you've got to be very careful about what goes in the bottom of your derivatives. You will encounter problems where it will be d over dx, sometimes d over dt, sometimes d over dh, sometimes d over d theta, sometimes d over Arthur's younger sister, dw. So, questions? Dolores Winifred, right? You're like, what are you talking about? Yep. Take it for Andrew. Okay. No, that's not enough. Okay. Questions? Okay. So then plus. Let's see. Now it's the first multiplied by the derivative of the second. Question. So a related rate problem is actually a problem that you solve without any integration at all. It just seems to fit better at this point in the year than it does earlier. So now I have dv over dt will equal 1/3 pi, parenthesis, h, okay, dr over dt. You have to use the power rule. So you bring down the 2, multiply by the r, new exponent would be 2 subtract 1. Last part of the power rule would be dr over dt. And I'll have a plus, pause there. Anyone need to talk about getting to that point? That's all review. It's not new, although it seems kind of new because we're using a lot of new symbols, but the rules haven't changed. Questions? Sweet. Oh, before I forget, I hope my text was clear. As I started looking at a way to help everyone who is really motivated to get an A for this term, but also help you stay on track for the AP test, I decided that rather than have a special quiz for extra credit to get you to that A, if you scored 82 or higher on the test, if you simply will honestly and sincerely complete all of the homework for Unit 5, I will award you enough extra credit to get to an A. Like, that's what I want you focused on, is making sure you can get through all of the homework that has been assigned for Unit 5. So, questions about that? Was a text the other day. So. Awesome. Got to finish here. R squared dH dt, that's it. So okay, I finished the algorithm. I have finished the algorithm. I have a new equation in all related rate problems, all of them. Somehow you're going to use this equation to answer whatever it is they're asking. You will use the equation differently depending on the problem, but you always use that equation to answer whatever it is they're asking. In this case, it's actually fairly straightforward. So raise your hand and tell me, what are they asking and why does that equation help? Hands up. What are they asking? Why does the equation help? Got to get more hands. Feel free to talk. Talk until you can raise your hand as well. Okay, hands up. In all related rate problems, in this moment you finish the DREAD algorithm, acronym, whatever you want to call it, the sequence. You somehow have to use the equation you just created to solve the problem. So hands up, come on. How do we use that equation to solve the problem? Somebody new here? So Carl?
So you can start plugging in like different values for like just because we know the d of h over d of t is at negative 0.3.
So let me summarize as you're talking. So that's very good. I know the height is changing at a rate of negative 0.3. So this brown item, I can plug in place of that symbol, negative 0.3. Keep going.
And then you have to figure out the rate of which the R radius is changing.
Pause it for 1 moment. So Carl's looking right here and he says, yeah, I don't have a value for that. They didn't give me one. So obviously I've got to figure out how fast the radius is changing. Keep going.
And then which, I don't know. Then you have to plug in H and R and you have to just go and find them for the time of, or no, you don't have a time. So, no, you do have a time. you have h equals 5.
Here we go.
So you plug, sorry, so then you plug that in.
So, no, it's perfect. If you had your hand raised, give yourself 2, 3 for Carl. They don't give us a time. They simply say it's whatever time it is, and at that moment, the height is 5. The height isn't always 5. It's just at that moment, the height is 5. Please don't make this crucial error. 1 second, Jack. Don't put 5 here. I'm going to break out the stick and start whacking. Don't put 5 there because the height isn't always 5. It's just 5 at one moment. Once we complete our analysis, we can say, hey, I want to go find how fast the volume's changing at that moment. Now we can plug in 5. Jack, please.
Since it's a right circular cone, wouldn't the radius at height equals 5 also be 5?
Close. 2 points for Jack. Close. Anybody else? Please, Dan.
So this is Jacob's idea, and I like it. So we know that the...
Whose idea?
It's Jacob's.
Oh, Jake, there you go.
But we know that the radius, when it's full, is 5, and since the height of 5 is halfway up, would the radius just be half of 5, being 2.5? Is that correct, thinking?
It is correct. Look up. Let me make sure everyone can see it. And let me show you something. So in this case, it's actually not too bad to kind of look at it and deduce that, hey, this starts out at 10, which means the radius, half of that is 5. So their thought was, well, when the height shrinks to 5, won't that make the radius shrink to 2.5? Right? That's what you're saying. That is true. You do have to have the mathematical rules to make sure on more complicated problems. So let me show you the idea. Okay, related rate problems are very, very commonly involved with geometry. They can make them other ways. They just have a habit of making them associated with geometry. So an idea that you should have learned at some point in your past, if you haven't, no worries, just learn it today. It's not hard. Is the idea of similar triangles. And one of the things they love to do on the AP test is create a situation where you have a right triangle within a right triangle. Not if you see what I'm talking about. Matt, please. Oh, you're good. Sorry. So, look, whenever you have that situation, a right triangle within a right triangle, that means you can write a proportion for the sides of the triangles. And the good news is you can kind of write the proportion any way you want. And it always works as long as you have a logical consistency or pattern. So what I would do is I'd say, well, they didn't give me any information about the radius. So let's just write down R. Because that's what I'm trying to figure out, R. And now I just make a comparison. I say, well, I want to compare this to the height. Because the R is this side of the triangle, the height is this side. I like my symbols in the numerator, so I don't have them in the denominator where it's harder to deal with. So I just write down R and H. They don't equal each other at this moment, but now I just build a proportion. I say, okay, R is to 5 as H is to 10. In other words, one more time, all I did was I compared sides of the triangle. I said the purple side of this small triangle compares to the blue side of this large triangle in the same way that the, I don't know, brown side of the small triangle compares to the green side of the large triangle. And that's how you do a similar triangle comparison. You would need me to go through it more different again. So sure enough, if you simply multiply both sides by 5, you discover exactly what Daniel told us. The radius is equal to exactly 1/2 the height. Or if you prefer decimals, 0.5 times h. So now we know how to find the radius. For the equation we had right here, we can plug in place of r, we can actually just plug in half the height, so we plug in 2.5. The radius is going to be half the height, we plug in 2.5. Questions? Carl?
The change of radius, or like the isn't that just that equation you had right there, r equals 0.5 of h? Could you plug that in as the change of radius?
So, take it for that one. That's again goes back to the idea of, I'll get you to answer it yourself. Does this symbol represent what the radius is, or does this symbol represent how fast the radius changes?
That's what the radius is.
Right, so that's amount. So that goes here. So what symbol goes here, Carl?
Rate.
The rate. And what symbol would represent the rate at which the radius changes? Look back here. Look at this equation. We have height. The rate at which the height changes is this symbol. We have volume. The rate at which the volume changes is this symbol. So what's the symbol that represents how fast the radius is changing? dr over dt. You need me to talk more about that. I would argue that this problem is one of the first times that you have ever experienced a problem where you're really applying a lot of different ideas simultaneously. Like it's reaching a level of complexity that really pushes your brain to think. Like you can't just memorize. I have to find this because right here, I need it. You all have the tools. You've already been taught how to find dr dt. Who knows how? There we go. There we go. Let's go mild. So right here I have an equation for r, which means if I take that equation and I apply the derivative operator to both halves of that equation, so I go ddt of r, and I go ddt of 0.5h. Now I have dr dt. 0.5 is a constant. I have found what I need for dr dt. Because I know dh dt is negative 0.3, so dr dt could be thought of as being negative. Oh yuck, I don't want to multiply decimals without a calculator. I'll make a mistake for sure. So I have a better plan. Who knew this before Miles said it? 2 points, 3 for Miles. Question? I have a better plan. It's an FRQ. I don't need to do computations. I just need to plug stuff in. So I'm going to write dv dt equals 1/3 pi, parenthesis, the height is 5, or yeah, 5, multiplied by 2. The radius is 2.5, that has to be squared. dr dt,
Squared minus 4. Because you had to apply power.
oh thank you, it's the first power. 2 for Edward. So just 2.5. Then it's minus, no plus, sorry. Oh, drdt. drdt is 0.5 multiplied by dHdt, which was negative 0.3, plus r squared, which would be 2.5 squared, dHdt, which is negative 0.3. And now I just need to make sure I have all the right parentheses. So we've got to have another one here to match this one. You need me to talk through any of that. This is why the FRQ is going to be the favorite part of the test. You don't have to do anything else now. You just stop and collect your points.
That's it?
That's it.
The purple is, okay.
Okay, whatever. That's just the rule of the test. You don't have to keep going. You do have to show units of measure, so look at what you're finding. You're finding how fast the volume changes in terms of time. So because they're measuring things in centimeters, the volume is going to be centimeters cubed. And because we're measuring time in, what is it, hours? Yep. That will earn you between 3 and 4 points on the AP test, which is good news because now you just picked up 4 points. That means only 56 to go to get a 4.
Yes, sir. You got this.
Sweet.
Easy peasy.
Questions? Please.
So it said find this with respect to time. So by saying dv over dt, that's the only time we really, acknowledge time. Is that enough? You don't have to have t in there.
I'll pay for that one. Yeah, respect, that's such a good question. Respect to time doesn't mean in terms of time. So let me see if I can just clarify that. This equation right here, there's no t in this equation anyway. But you know the height changes as time goes on. You also know the radius changes as time goes on. So this is definitely an equation that depends on time. Is that fair?
Yeah.
So it's not in terms of time because there's no t in the equation, but it's definitely a function of time because it depends on it. With respect to time means how is the volume changing in comparison to time? And this says, like we cheat and we look in the back, the answers, we find that if you work it all out, you get this value. So that says that your volume is going to go down by that many cubic centimeters every hour. That's what they mean by respect to time. Like, how is the volume changing in comparison to how the time is changing? And that's how all rates are written. All rates are a comparison between two things. I don't know if that helps. Okay. Anybody else? Sweet. You're all thinking, yeah, let's look at the clock. That took us 50 minutes. That was one problem, 12 to go. Sweet. All right. As always, it gets faster once you kind of work on it. Okay, anything about that first discussion you want to, like any part of it that your brain's saying, I couldn't follow this idea. Talk to me. Please.
Like when you have the radius over time,
You're okay. So you're talking about when we were looking at the triangle?
Yeah.
Gotcha. Let's just go through it one more time, if that's okay. Page 1-3. Everybody, look here. Come on, look. The idea of a similar triangle is very, very common in a related rate problem. So make sure as we talk about this, any question that comes to mind, just stop me and ask me to repeat or whatever. Basically, all you have, so are you okay that there's a right triangle within a right triangle? Okay. So all you have to do now, Miles, is pick any side. So there's my small triangle. Here's my large triangle. The nice thing about a similar triangle comparison is you can actually pick anything you want. So you tell me any side of either triangle. Just pick any of them. I don't care.
I guess like the side of the small one, like side R, and then.
Okay, so stop there. So we're going to pick the short side of the green triangle. And you just write it down. So you have to have something to represent that. Just, they called it R. I'm going to put it on the bottom this time. I don't care. Okay, now you just pick, well, you choose. You either choose, how do I say this? You either, let's just keep going. Pick some side, now pick the side of the big triangle that corresponds.
That would be the short side.
Short side of the blue. You happen to know that's 5. So you can put that either here. That makes sense for the proportion because you're like comparing. Or you can actually put it here. That also makes sense. You can't put it there. So let's do this. Okay with that? Okay, so you compared the short side of the small triangle to the short side of the large triangle. You now make the exact same comparison with some other side. So that means, let's see, this was the short side of the small. This is the short side of the large. Therefore, you got to compare sides of the, like what would go here logically? Say again. So I'd say, okay, so this was the short side of the small. Oh, so let's go the long side of the small. That's H. Which now we need the long side of the big, which would be 10. Is that okay? So look at the board, look. Okay, simple math idea. If you have a fraction that equals a fraction, that means the reciprocals are equal? It should feel like common sense. Like, look at the equation. The only way you can have this equal this is if the tops are the same and the bottoms. It has to all work out. So just flip it, because I don't want the R and H on the bottom. So just go R over 5. The same thing as H over 10. And then multiply the 5 across, and I have exactly what I found before. Similar triangles are really easy. You make any comparison you want, as long as your brain says, yeah, that's logical. I'm not just plugging stuff in. That helps. Yeah. Okay. Anybody else? Yeah, look at me. We're going to keep going here for another few minutes, but look up. Don't miss the announcement. Okay. You actually are prepared. You have the tools you need to solve all other 12 problems in the packet. However, you can sense by how this works that it does take some time to get good at it and to get efficient at it. So, as far as homework, you have one of two options. Either, okay, everybody look at me. If you're not getting your homework done, you have got to make a life adjustment. I'm not kidding. Like, you've got to cut something. Like, you can't just keep going on saying, I will get it done someday. No, something else has to go. And if you're at the point where you're like, I just don't have time for this, and one of these is calculus, that's your choice. Like, you and your parents have to figure that out. But often there's something else that can be cut. You just have to decide. You can't keep going on saying, I don't have the homework done yet, but I will. Like, you got to get it done. So your choice today is this. Either spend the time between now and Monday catching up on homework you haven't got done, with the idea that you're going to have to attack the green hard on Monday, or try to get through some of the green. You don't have to get through all of it. because we're going to continue this discussion on Monday. So I'm not technically assigning the green homework today. You have it in your hands, so if you're caught up, I would get going on it, I wouldn't wait. But if you are behind on other things, cut something else out and get going on it, okay? But you can't just keep waiting. We are only 2 packets away from starting our practice of the AP test. I guarantee you, the first AP test I give you, do not expect a good score. It's a process. Like, we take a test, you see what score you get, you go, that's horrible. Like, who cares? It's only March. Okay? I can learn from what I did and get better. And then 10 AP tests later, you'll be amazed at how well you are scoring. Okay? That's how we get ready for the test. It's simple. It's just like anything. You get ready by working on it. So, anyway, a little short on time, so I don't want to start fresh. Only got 3 minutes left. But again, so I'm not assigning the green, but get caught up on other homework, or you can start working on the green. If you work on the green and you make progress, great. If you get stuck, stop. We're going to talk about it more. There will be 5 videos posted, and I'll try to make some more as well. But anyway, good work.